Q9797-1. You touch down long with a speed of 145 knots on a 9,001-foot runway, and the braking is not working, so you decide to take off and climb out. The engines require 5 seconds to spool up, and then the airplane requires 10 seconds of acceleration time to lift off again. The 5,000-foot marker flashes by. Do you have enough runway to lift off? Use 132 knots for the average ground speed. A. Yes. There will be a margin of 850 feet and almost 3 seconds of decision time. B. Yes. There will be a margin of 2,001 feet and almost 5 seconds of decision time. C. No. The runway is 1,340 feet too short, and my decision is about 6 seconds too late. The correct answer is B. 1 knot equals 1.69 feet per second. Thus multiply 132 knots by 1.69 feet per second to get 223.08 feet per second. Calculate liftoff distance. The required liftoff distance is 3,346.2 feet for a total liftoff time of 15 seconds, 5 for spool up and 10 for liftoff. Determine the remaining distance at the 5,000-foot mark. 5,000 to 3,346.2, liftoff distance, 1,653.8 feet. 4. Determine the amount of time available to make a decision by multiplying 1,653.8 by 223.08, distance traveled per second, to get 7.41 seconds. 9,797-2. You touch down long with a speed of 145 knots on an 8,501-foot runway, and the braking is not working, so you decide to take off and climb out. The engines require 5 seconds to spool up, and then the airplane requires 10 seconds of acceleration to lift off again. The 4,000-foot marker flashed by 2 seconds ago. Do you have enough runway to lift off? Use 143 knots for average ground speed due to the tailwind. A. Yes. There will be a margin of about 850 feet, which is almost 3 seconds of decision time. B. Yes. There will be a margin of almost 101 feet, which is about 1.5 seconds of decision time. C. No. The runway is 99 feet too short, and my decision was about 0.4 seconds too late. The correct answer is B. The airplane has traveled 483.34 feet, which can be determined by multiplying the distance covered per second at 143 knots, 241.67 feet per second, by the amount of time past the 4,000-foot mark, 2 seconds. The remaining runway is 3,516.66 feet when this distance is subtracted from the marker's distance for 1,000 feet. A deficit of minus 108.39 feet, or insufficient runway, is found when a complete liftoff duration of 15 seconds, including spool up, is taken into account, which necessitates 3,625.05 feet of liftoff distance. This means that there is insufficient runway for a safe liftoff. 9801. One typical takeoff error is A. Delayed rotation, which may extend the climb distance. B. Premature rotation, which may increase takeoff distance. C. Extended rotation, which may degrade acceleration. The correct answer is A. Because the pilot not flying will call for rotation at, or just past, VR, it is usual for the pilot to overshoot VR and subsequently overshoot V2 during training. The flying pilot's response is to spin after visually confirming VR. Then, the aircraft lifts up from the ground at or above V2. On a typical takeoff, the additional velocity might not be a big deal, but if the runway is short or there are obstacles in the way, it may be crucial to avoid a delayed spin. 9802. Excessive takeoff speeds may result in approximately A. 4% takeoff distance increase for each 1% of additional takeoff speed. B. 1% takeoff distance increase for each 2% of additional takeoff speed. C. 2% takeoff distance increase for each 1 inch/0 of additional takeoff speed. The correct answer is C. The early rate of rise and feel of the airplane may be enhanced by a high takeoff airspeed, but the takeoff distance will unintentionally increase. The takeoff distance varies as the square of the takeoff velocity, assuming that the acceleration is unaltered. Therefore, a 10% increase in excess airspeed would result in a 21% increase in takeoff distance. 8400. At what speed, with reference to L/dp1I, does maximum rate of climb for a jet airplane occur? A. A speed greater than that for L/dmax. B. A speed equal to that for L/dmax. C. A speed less than that for L/dmax. The correct answer is A. A speed greater than that for L/dmax. The maximum rate of climb for a jet airplane occurs at a speed greater than that for L/dmax, which is the speed that maximizes the lift-to-drag ratio. While L/dmax represents the most efficient flying speed, it does not necessarily correspond to the maximum rate of climb. During climb, the aircraft needs to generate enough lift to overcome its weight and maintain an upward trajectory. The maximum rate of climb is achieved when the aircraft is operated at a speed higher than L/dmax. This speed allows the aircraft to generate sufficient lift to climb at the highest possible rate, even though the lift-to-drag ratio may be slightly lower than L/dmax. Therefore, the maximum rate of climb for a jet airplane occurs at a speed greater than that for L/dmax.